Good morning.
Good morning.
Morning.
Okay, so let's get started. I am here to answer any questions anyone may have. So where should we start? Does anyone have any questions? Chapter 7, Chapter 8, the extra credit assignment, the quiz, anything we should talk about? Well, I hate to end the meeting so soon, but if there's no questions, then there's really nothing to have a meeting about.
I'm planning on taking the quiz later today, so that's why I don't have any questions yet. I already did the homework, but so I wanted to see, like, in case someone already took it and had questions. But is it okay, like, if I emailed you throughout the day if I have any questions, or like you wouldn't get back to me today?
I will try to get back to you today. I have, I'm looking at my schedule. 1, 2, 3, 4. I have 6 Zoom calls today between now and 6 p.m. So I'll do my best to get back to you today.
Mm-hmm.
May not be till the evening or till tomorrow.
Mm-hmm. Okay. Yeah. I just, like I said, I haven't attempted to take it yet, but I'm planning on doing it later today. But thank you.
You're welcome. And this is for everyone, even if you've done the homework already. If there's something on the homework that even though you got right, if it took a couple of attempts or a few attempts to get it right, those are also questions that, it might be helpful to discuss. No pressure. I just want to make sure I'm here to answer any questions anyone has.
Can I ask you a question, Professor?
Yes, of course.
Um, the difference between the t-score and the z-score is just like as I've understood it. I don't know if it's the right way to describe it, but I know that when it's a z-score, it has to be, the sample size has to be 30 or more, and you have to be simple, a random thing, and then what is it, the standard deviation? If the standard deviation is given and the sample size is greater than 30, we use the z-score. Otherwise, we use the t-score. Is that how it goes?
If the population standard deviation is given, yes.
Yeah. Okay.
You would use the z-score.
Yeah.
If that's not, yeah, exactly. If that's not given, you would use the t value. You could call it t-score. That's fine.
Oh, okay. I was just like, when you calculate, there's like a table and you calculate the whole thing to find the standard deviation on on a table, and then you get the average. You still can use like the z-score instead of the t-score, right?
Yeah, you have to use the z-score. Yeah.
Yeah.
If you're calculating the standard deviation,
Yeah.
then you have to use a z-score.
Okay. Okay. It's just a little bit confusing. That's why. Thank you.
You're welcome.
Yes, I had a question. I think it was on this week's homework, number 16. It was on using the critical value method to solve the problem.
Okay. Yes. What's the question specifically?
I was just confused about using the critical value method. I think it was one of the ones where I was getting confused with the significance and whether the the alternate hypothesis was, or the null hypothesis was equal to. I didn't know if you had to split there's a two, whether the two-tiered test made a difference for the significance.
Are you referring to a question from the homework?
Yeah, it's number 16.
Okay. Yeah, that's what I needed. Number 16. Okay. So let me pull up number 16. Okay, so you're talking about this one?
Yes, that one.
So in this case, the claim is already given, right?
Yep.
The claim is given that P equals 3/5, or you could convert that to 0.6, either way. And then once you have the claim, the next thing you do is determine what is your null hypothesis and alternate hypothesis. Okay. Okay, sorry, I misplaced my pen. Okay, so we're given, so let's see, draw. You always start with the claim. After the claim, you set up your hypotheses. Now, was your question about choosing the hypotheses?
I'm sorry, it was the significance level and finding the critical value.
Okay, so hypotheses, the null hypothesis is always equal to. And the alternate hypothesis would be not equal to. So are you clear on why it's equal and not equal?
Yes, I am.
Okay. So that tells you so this is what tells you it's a two-tailed test, the alternate hypothesis. So that means the critical region is split both ways. So this is an area of alpha over 2, and this is an area of alpha over 2. So in this problem, alpha is given as 0.05. So half of that is 0.025. And so now you need the critical values. So this is the question?
Yes.
Okay, so this is the same question from chapter 6 and chapter 7. We you know this nothing, you're not doing anything new.
Okay.
I don't want you to look at this as like something new in chapter 8. This is what we covered in section 6.1. So you could find either one. It doesn't matter which one you find. They're going to be the same number because it's symmetric. One's going to be positive and one's going to be negative. So if you wanted to find this one, for example, you would use equal norm dot s dot dist and oh, sorry, not distribution. Norm dot s dot inv, and the area to the left of this critical value that's half of alpha, 0.025. So that should give you, oh, where's my keyboard? Oh. That should give you, I believe, 1.96. So equal norm.s.inv. So that's if you know the area to the left of a z-score and you're looking for the z-score, this is the function you use. And yeah, 1.96. Well, if we round it to 2 places, this is the same 1.96 we saw in chapter 7. So this one's negative because it's on the negative side, and the other one would be positive 1.96.
Okay, so on the single tiered test, is there just one critical value? Like here you have
Yes.
2? Okay. All right, that makes sense.
And now the test statistic is given in this problem. It's given as negative 2.26. So that test statistic is over here. Right, because here's 0, positive on the right, negative on the left. And the test statistic is given in the problem as negative 2.26. So since that test statistic is inside the critical region, that tells us to reject the null hypothesis. Okay, does that clear it up?
Yeah, it does. Yes, thank you.
And so if you were doing a full hypothesis test, so this is just asking about parts of the test. This is saying, like, what's the critical value and do you reject the null hypothesis, yes or no? If you were doing the whole full hypothesis test, you would go one step further. So this decision to reject the null hypothesis, that's always the second to last step in the whole problem. And if you were, I mean, if this was a question, next week in section 8.2, where it's do the whole hypothesis test, you're basically done here. You would just go to the flow chart, and I put it on the Excel worksheet that I made to make it very easy for you to reference. Hopefully everyone's already watched this video and gone through this worksheet, and then I had the 3 problems I worked through, where I basically went through every single scenario: left side, right side, left tail, right tail, two tail, proportion, mean with sigma, mean without sigma. So with these 3 problems, I basically did an example of everything you might see, and then on this fourth sheet down here, I just put all the sort of the important visuals in one place that you may want to definitely use this as a reference when you're doing the homework or doing the quiz, and next week as well. And so let me zoom in a little bit on the part that I'm referring to. So for the last problem we just did, does the original claim contain the condition of equality? Yes, it was given. The original claim was P equals 3/5. So the original claim contains an equal sign. Do we reject the null hypothesis? Yes. So that puts us in this first box. So the final, this is always your final answer to a hypothesis test. So in that problem we were just looking at, the final answer to the hypothesis test would be there is sufficient evidence to reject the original claim. Or basically the sample data is saying that the proportion is not equal to 3/5. Oh, I think I have these labeled incorrectly. I hope it's the right. Okay, yeah, sorry. This says 7. Okay, this is the wrong text, but when you click on it, it's the correct. Let me just make sure. Yeah, okay, that's good. Yeah, sorry, I need to change the text here, but this is the 8.1 lecture video and the 8.1 notes. Sorry about that. Okay, what else? Any other questions?
Are you still going to drop the lowest grade?
The lowest quiz grade.
The quiz grade. Okay.
And so you'll see that, once all the grades are in, when you click on the My Math Lab gradebook and you look at your quiz scores, you'll see the lowest one. It'll say, like, in parentheses, omitted next to the score.
Okay, thank you.
You're welcome. Okay, so now that is now the correct label. Okay, anything else while I'm on? Okay, so Good luck finishing up section 8.1. And I mentioned this at our last Zoom meeting earlier in the week. This week and next week, it's the same topic. So basically next week, it's the problems you see next week will just basically be take all of the individual ideas in section 8.1 and put them together in one, one big problem. So you want to definitely make sure before starting next week that you've asked all questions you have about section 8.1, because next week it's going to be sort of assumed you're able to use all of this stuff covered this week. And we are basically done. I mean, next week is it. Next week is the last week of lecture for the semester. And we then have the final exam, or not the final exam, the third exam, covering just chapters 7 and 8. Okay, everyone. As always, if questions do come up later today or over the weekend, please send them my way. Have a great weekend, everyone.
Thank you, you too.
You're welcome.
You too. Thank you.